Next up, we're going to look at writing inequalities, which should be almost the same as when we wrote expressions and we wrote equations. The only difference is knowing the words that are going to identify which inequality symbol to use rather than the equal sign. So verbal statements can be translated to algebraic inequalities, much like deciphering a secret message or translate from one language to another. These are the key words you're going to need to look at. These are words that tell you greater than, these tell you greater than or equal to, these tell you less than, these tell you less than or equal to. Being careful with like no more than. Sometimes people just read more than. You got to pay attention. It's no more than or no less than. Okay? So let's look at these first couple examples. A number is at most 15. So I'm going to circle the number. I'm going to highlight the word that tells me the inequality symbol. So at most. And it's usually going to be right before the number. And then our unknown is a number. I'm just going to use X for each of these, okay? So X is our inequality symbol, is at most. At most falls under less than or equal to. So less than or equal to 15. And that's it for that one. Number 2, the sum of a number and 3 is less than 12. So some keywords there. We see sum, which tells us addition, okay? Of a number, that's my unknown that I'm going to use X for, and then is less than. In this case, doesn't mean subtraction. In this case, it's talking about our total, so is less than 12 just means we are using the inequality symbol less than. So the sum of a number and 3, X plus 3, is less than, that's our inequality symbol, 12. And that's it. Number 3, the quotient of a number and -2 is greater than or equal to 10. So circled those numbers, underlining the quotient of a number, that's our unknown. And then keywords, quotient, which tells us division, greater than or equal to tells us the symbol is greater than or equal to. When we are doing the quotient, I am writing it as a fraction. So the quotient of our unknown number X and -2, so over -2, is greater than or equal to, so our symbol is greater than or equal to 10. And right now we're just practicing writing them. We will practice solving them momentarily. Number 4, 4 less than a number is at least -6. So 4 less than a number, our unknown number, is at least -6. Keywords. Kind of is confusing here. So if you point them both out, we see less than and at least. It's not 4 is less than, it's just 4 less than, which means it's subtraction. And is at least tells us that is our inequality symbol. We're not going to have 2 inequality symbols, so if you're not sure if the less than's the inequality symbol, keep reading and you'd see that at least is. So 4 less than a number, remember subtraction, the order matters. 4 less than a number means I'm subtracting 4 from my unknown number. And that is at least, so it's greater than or equal to -6. Number 5, the difference between a number and 13 is at least 1. So circled those numbers, underlined my unknown number. Difference tells me subtraction and is at least tells me greater than or equal to. So the difference between a number and 13, when it says difference, we can go in that order. So it's the difference between X and 13. So X minus 13 is at least, so greater than or equal to 1. Number 6, 8 less than a number, our unknown number, is less than or equal to 5. So here's the difference. This just says less than, 8 less than. This says is less than or equal to. So where it just says less than, there's no is, that's subtraction. Here, when it says is less than or equal to, that is our symbol for inequalities. So 8 less than a number, again, that means we are subtracting 8 from our unknown number, and that is less than or equal to 5. Number 7, 3 times a number is more than -7. So our unknown number, keywords, times and more than. Again, the more than can be confusing just like less than, but it says is more than. So that means that's our inequality symbol, which is greater than, and the times is representing multiplication. So 3 times a number, we're just writing that as 3x, that means 3 times a number, is more than, so is greater than, -7. Number 8, 1/2 of a number plus 5 is greater than 11. So 1/2 of a number. That of there is telling us multiplication because it's a fraction with of. Plus tells us addition, and then is greater than tells us the greater than sign. So 1/2 of a number is just 1/2 times our unknown, so just 1/2 x, plus 5 is greater than 11. Number 9, -6 plus a number, so our unknown number, is no more than, not just more than, no more than 15. And as a reminder, no more than, it's kind of the opposite. It's not more than, it's less than. So it's less than or equal to. So -6 plus our unknown number x is no more than, so it's less than or equal to 15. Now let's do some where we're not only writing, but we are solving. So number 10, the sum of twice a number and 4 is at least 16. So twice a number, our unknown number, and 4 is at least 16. So we have sum, and, which also tells us addition, is at least 16. So we know we're adding, and then at least is greater than or equal to. So for our inequality, the sum of twice a number, so 2x and 4, so that sum plus 4 is greater than or equal to 16. Now we can solve. Two-step inequality, we're subtracting 4 from both sides. I get 2x is greater than or equal to 12. Divide both sides by 2. We get x is greater than or equal to 6. My variable's on the left, which makes it easy to graph. So this is going to be between 0 and 10. 1, 2, 3, 4, 5. 6 is right here. There's an equal to part, so I'm going to shade it in. My arrow is pointing to the right, so I'm shading to the right. Okay, number 11. 1/2 of a number less than 6 is greater than or equal to 10. So of, in this case, because it's with a fraction, is telling us multiplication. Less than is telling us subtraction, and greater than or equal to is telling us the symbol. So 1/2 of a number less than 6. So here's where it gets a little bit confusing. This 1/2 of a number is being subtracted from, because this is less than. So we are subtracting 1/2 of a number. from 6. It's 1/2 of a number less than 6 is greater than or equal to 10. Now to solve, we're going to get rid of the 6 on both sides. We are left with negative 1/2 x is greater than or equal to 4. We're multiplying by negative 1/2, so I'm going to divide by negative 1/2 or multiply by the reciprocal, which is essentially just multiplying by negative 2. So those cancel. We're left with x. 4 times negative 2 is negative 8. But since we multiplied by a negative, I need to flip my sign. Now I can graph because my variable's on the left. This falls between 0 and negative 10. Negative 8 is 1, 2, 3 right here. There is an equal to part, so I'm going to shade it in. Our arrow is pointing to the left. Number 12. 3 times a number increased by 7 is less than 11. So times tells us multiplication, increased by tells us addition, is less than tells us our inequality sign is less than. So 3 times a number increased by 7. So 3 times our unknown number, x plus 7 is less than 11. Now we can solve. Get rid of our constants. X is being multiplied by 3. The opposite is to divide by 3. It's a positive, so our sign stays the same. And we get a fractional answer. So either 4/3 or 1 2/3. I'm just gonna graph as I normally would, 1 1/3, not 1 2/3. Normally, I'm gonna do this in a range of 0 to 10, because that's where 1 would fall. 1, 2, 3, 4, 5. 1 2/3, well, 1 1/3. 1 is right here. 1/3 is gonna be right about here. It is not equal to, so I'm leaving it open, and our arrow is pointing to the left, so I'm going to shade to the left. Number 13, the difference of 2 and a number is at least -1. So difference, subtraction is at least is our inequality sign and our unknown number. So the difference of 2 and a number. When it's difference, we go in that order. So 2 minus our unknown number, x, is at least greater than or equal to -1. When we're solving, I'm getting rid of my constant by subtracting 2 from both sides. Be careful as you bring this down. We're left with -x is greater than or equal to -3. We need this to be positive though, so divide by -1 or multiply by -1, and we get x, we get +3. Since we divided by a negative, our sign needs to flip in the opposite way. And now we can graph. This falls between 0 and 10. 3 is at 1, 2, 3 right here. There is an equal to part, so I'm going to fill it in. The arrow is pointing to the left, so I'm going to shade to the left. Number 14, the quotient of a number and 5 is no greater than -9. So quotient tells us division, no greater than, even though that's not directly listed. No more than and no greater than are the same, because more and greater are equal. So no greater than is going to be less than or equal. So the quotient of a number and 5, we do it in that order. The number on top, 5 on the bottom. No greater than is less than or equal to -9. And now we can solve. X is being divided by 5. The opposite is to multiply each side by 5. Those cancel. We're left with X. On the right side, -9 times 5 is -45. We were multiplying by a positive, so our sign stays the same. -45 falls between -40 and -50. 1, 2, 3, 4, 5. -45 is right here. There's an equal to part, so I'm going to fill that in. Our arrow's pointing to the left. Last one. 20 less than twice a number is at most 10. Keywords, less than, and it's just less than, not is less than, so that's talking about subtraction. Plus we have our inequality sign here, is at most 10. So 20 less than means I'm subtracting 20 from something. What am I subtracting it from? Twice a number. So I'm subtracting it from 2x. Is at most, if you don't know, okay, at most we have right here is less than or equal to. So is at most 10. Now we can solve. Add 20 to both sides. We get 2x equals 30. X is being multiplied by 2. The opposite is to divide each side by 2. And we get x is, whoops, that should be less than or equal to 15. It was divided by a positive, so our sign stays the same. 15 falls between 10 and 20. 15 is right here. It has an equal to part, so we're going to shade that in. Our arrow's pointing to the left, so I'm going to shade to the left.